Hello friends, welcome back to the class of thermodynamics. In previous session we have seen about two statements of second law of thermodynamics, Kelvin Planck statement and process statement. The heat cannot be transferred from low temperature body to high temperature body without help of any external agency. Okay. Now, based on this thing, there are two devices. One is refrigerator, another one is heat pump. So in today's session we will look after refrigerator and heat pump. Now, you are familiar with refrigerator. Refrigerator, another name is fridge. Everyone is having fridge in their home. What for which purpose the refrigerator is used or fridge is used? For cooling any food product, food item, cold drinks, vegetables, anything, food items. You cool it. So you keep it in refrigerator, okay? Correct? So you keep hot thing inside the refrigerator, it becomes cold. Cool means its temperature become less than the temperature of surrounding. Next thing is heat pump. Now, what is heat pump? So, before getting to heat pump, you have seen water pumps or air pumps. Everyone has seen water pump in your home. What is the function of water pump? It pumps the water from one place to another place, from ground to height, up to some altitude. It is pumping water. Same thing, there is heat pump which is pumping heat. Okay, so we will see what is refrigerator and what is heat pump. Now, before going to heat pump and refrigerator, first we see heat engine. We already talked about heat engine. There is one source at temperature T1 which is high temperature. There is one sink which is at low temperature T2. Now this is nothing but your system heat engine. So it is absorbing heat from source Q1 amount of heat and rejecting Q2 amount of heat while doing some amount of mechanical work W, and by energy balance you will get W equals to Q1 minus Q2. Correct? Correct? So this was heat engine. Now we talk about reversed cycle heat engine. Correct? This is heat engine, or now here we are talking about reverse cycle heat engine. Now what is reverse cycle heat engine? Again see it carefully. What this is heat engine is doing? It is taking heat from source. This is the system. This is the heat engine, which is the system. It is taking heat from source Q1, rejecting heat to the Q2 to the sink, rejecting Q2 amount of heat to the sink, and doing some work output equals to work W. This W is equals to Q1 minus Q2. Remember this thing. Now we are talking about reverse cycle heat engine. What is reverse cycle heat engine? It is a cycle heat engine which extract heat from cold body and reject it to hot body by consuming external work. This is nothing but something related to Clausius statement. Means it is taking heat from cold body and rejecting to hot body by taking some amount of or by consuming some amount of external work. Means we are doing some amount of work on the system to transfer heat from cold body to hot body. And the examples for this kind of reverse cycle heat engine is heat pump and refrigerator. Now what is heat pump and what is refrigerator? Heat pump is a device operating in a cycle, maintains a body at a higher temperature than the temperature of surrounding. Means it is taking heat from surrounding and throwing to the body, increasing the temperature of the body. The main purpose is to increase the temperature of body more than the surrounding temperature. Okay, so heat pump is taking heat from surrounding and throwing it to the body to increase the temperature of body higher than the surrounding temperature. This is the desired effect. What we want? We want to heat a body. We want to increase the temperature of body. How we will do it? By taking temperature from surrounding and supplying it to the body. So this is our desired effect, heating the body. This is the heat pump. Heat pump is a device which is doing this thing. It is increasing the temperature of body more than the surrounding temperature. Next, refrigerator. Refrigerator is just opposite. Now, in refrigerator, what is our main purpose? To cool the body. Heat pump is used to heat the body. Refrigerator is used to cool the body. For how much temperature? Lower than the temperature of surrounding. Okay, right? So refrigerator is a device operating in a cycle, maintains the body at a temperature lower than the temperature of surrounding. If the temperature of body is lower than surrounding, then only we say it is cool. Okay, so desired effect is to cool the body. So if you will say, or someone will ask you, what is the desired effect in the case of heat pump? You will say to heat the body. And what is desired effect in the case of refrigerator? To cool the body. Correct? So these are the two applications of reverse cycle heat engine. Now, coefficient of performance. Now, coefficient of performance is also in short known as COP. In short, we call it as COP. Now, what is this thing? If you remember, in case of engine, we talk about efficiency. Similarly, here we talk about the performance, coefficient of performance. How much is the performance of the device in terms of coefficient of performance? See, measure of performance of heat pump or refrigerator is called coefficient of performance. In short, COP. COP or coefficient of performance both are same. It is the ratio of desired effect to net work done. It is the ratio of desired effect to the net work done. Correct? Note down this thing. Next, formula of COP, desired effect per net work done. Now what is desired effect? Just now I told you, in the case of heat pump, what is the desired effect? Heat pump is used to heat the body. And what is the desired effect in the case of refrigerator? To cool the body. Correct? And net work done, it is nothing but Q1 minus Q2 from the energy balance. Now we will see here. Figure A. This represents the refrigerator. Refrigerator purpose is to cool the body. To cool the body. So here there is one environment or surrounding you can say, and surrounding will be at high temperature. This is our system refrigerator. This is cold space, means where our body is here. We want our body to be cool. So here is our body. We want to cool the body. So how we will make it cool? We will take heat from it. We will extract the heat from the body. Then only it will become cool. So we will extract the heat from the body. So this is R is nothing but refrigerator. It's a device which is extracting QL amount of heat from the body and supplying this to the environment or surrounding, which is at higher temperature. How it will do? I already told you. If you want to transfer heat from low temperature body to high temperature body, you have to get some amount of work input. So this is W net is nothing but required input, and this QL is nothing but desired output or desired effect. Why? This is our body which we want to cool. So the heat coming out from the cold body is our desired effect in the case of refrigerator. Now this is understand. Now coming to second case, figure B. This is heat pump. Now heat pump, our main purpose is to heat the body. So this warm house is nothing but our body which we want to keep hot. So how it will keep it hot? when it will take it from surrounding and throw this heat to the body. Then only it can maintain the temperature of body higher than the surrounding. How it will do? Again, it will absorb some amount of work or energy. Correct? So see both the figures. Same thing is there, only our desired effect is changed. In case of refrigerator, our body is in the cold side. In case of heat pump, our body is in the hot side. Now, you can say, so example, suppose in the case of winter, in winter what you want? You feel cold, so you want to heat your house. You want to heat your house. Okay, so this is case of heat pump. Now, second case, in refrigerator, you want to cool the body. You want to cool the vegetable or any such food substance. Okay, so you take heat from the body and supply it outside to the surrounding environment. Correct? Only the thing is our location of body is changing. Work is same, on the location of body and surrounding is changed. Correct? Based on this, our desired effect is changing. So from here comes the COP. So what will be the COP in the case of refrigerator? See, COP is nothing but desired effect by W net. In case of refrigerator, our desired effect is QL and W net is nothing but difference of these QH minus QL. So we can write what we can write. We can write that COP in case of refrigerator is given by desired effect. Desired effect is how much? QL and W net. W net from heat balance it will come difference of both the heat. High minus low. High minus low. Correct? Similarly false heat pump, COP of heat pump, how much? What is the desired effect? Desired effect is QH, which is going inside the body, which is heat going inside the body. This is QH. Divided by W net. W net is same. QH minus QL. Okay. So this is a case for the COP of refrigerator. This is case for the COP of heat pump. Correct? Now, one more relationship you can get from both the things. What is the relationship? Suppose COP of HP, COP of HP minus minus COP of refrigerator, COP of HP minus COP of refrigerator. How much? See, denominator is same. Denominator is same in both the cases. So take it out. Common QH minus QL. This is the denominator. W net same. Now COP HP minus COPR. COP HP QH minus COPR means QL. Correct? Now these both will cancel. It will become 1. Right? So you can get this relationship. COP of heat pump minus COP of refrigerator is equals to 1. So we can say COP of HP is always greater than COP of refrigerator by quantity 1. If in question COP of refrigerator is given, just add 1, you will get COP of heat pump. Right? This is a important conclusion. Note down this thing. Formula for the COP of HP, formula for the COP of refrigerator, and the relationship between COP of both things. Note down this thing. See, same thing I have written here. COP of refrigerator and COP of heat pump. Correct? So, same thing is here. I have written the formulas and this is the relationship I told you. Now, one more important conclusion. COP of heat pump will be always greater than 1. Why? Because it is 1 plus COP of refrigerator. So it will be always greater than 1. But what about the efficiency? Efficiency is always less than 100% means less than 1. So COP of heat pump is always greater than 1 and efficiency of engine, thermal efficiency of engine is always less than 1. These are also one of the important conclusions. So note down these things also. This whole slide is very important. Note down all these things. Very important thing. So I hope the things or the fundamentals are clear in today's session of refrigerator and heat pump. You came to know about the working principle and how you will found the coefficient of performance of pump as well as refrigerator and how you will find the efficiency of heat engine. Here, thank you for today's session. We will meet you in the next session of thermodynamics. Till then, goodbye and take care.